Hi guys, we're looking at linear programming today, so I'm just going to do one example. This is one of the ones that you have set for you. So this can help us solve problems. We've got a car park that has space for X cars and Y motorcycles, and the area is 900 meters squared. Each car needs 15 meters squared of space, and the motorcycle needs 3 meters squared of space, and there must be space for at least 40 cars. There must be space for at least 20 motorcycles. Explain why 5x plus y is less than or equal to 300. Okay, so straight away, we know that each car takes up 15 meters of space, meters squared, and each motorcycle needs, so let's go 15 times the number of cars plus 3 times the number of motorcycles has to be less than or equal to 900. That's how much space we've got in the car park. Now if we divide that by 3, we're going to get 5c plus y is less than or equal to 900. And it says x cars and y motorcycles. So let's just switch those variables there. So that will be x, and we're going to switch the motorcycles to y. Okay, so that will be that. So we've proved the first. And we've got to divide the 900 by 3 as well. So obviously that's going to be 300. So we've proved that first one. Now the second thing is write down 2 more inequalities. Well, there must be space for at least 40 cars. So C is greater than or equal to 40. And the other one is it must be space for at least 20 motorcycles. So, not C. Remember, cars is X. And then for motorcycles, Y is greater than or equal to 20. And we've got to represent them on the graph. Okay. Well, let's see. We need to go up to 300. What can we do? 50, 100, 200, 300. I think we can go. Let's try this. 100, 200, 300. Okay, so that's that way, and then going along the other way. I think we can do the same. Not if we want to go that far. Let's see. Oh, bother. 200 is there. And 300 is here. Okay, so the first graph here, we're going to plot this one. So 5x plus y equals 300. Well, if there are no x's, that means that we could have, so we'll plot this with a pink. If there were no x's, that would mean we could have 300 y's. And if there were no y's, 5x times what is 300, so that would be 60. So 25, each of these squares, little squares, is worth 5. 25, 50, 55, 60, so that would be there. So I would need to draw a line between there and there. Now, I can't do this very easily on screen, but there's my best attempt. Okay, there's my line. Now the next one, so I didn't need quite so far on my x-axis. The next one is x is greater than 40. So we'll do this with the blue. Now this is 25 here, this is 50 here, so we're just going back to from there. So I think this is 40 here. So x is greater than or equal to 40. It's going to be a vertical line that goes all the way up here. And we want greater than, so that means we're shading off anything that's less than. So shading off this here. Alright, and I should shade off the pink. I want the pink, we're shading off everything over here. So obviously you could do this a lot neater than that. And then the last line that we're going to do, we'll do a green line. Y is greater than 20. Well, 25 is here, so 20 is this line along here. And we want y being greater than that. So we're going to color out all of this stuff here. Which leaves us with this beautiful triangle, which I'll highlight here. Oh, let's try it with a highlighter, shall we? So this bit here is the region that we've defined in here. And that leads us to D. What is the largest possible number of cars in the car park? Now remember, cars is your X values. So the largest possible number, I think, should be this value here, which looks to be maybe 55 according to my graph. Now, you'll be doing it a lot more accurately because you'll have rulers and all of that sort of thing. But according to the question here, it says 56. So if I was to do this again, I would probably change my scale along the bottom. So I suggest that when you do this, you change your scale and make a wider scale, because you only need to get up to, I think it's 50 or something, well, just over 50. So if you pushed everything out this way, it'd be much easier to see. Alright guys, I hope that gives you a good introduction to linear programming. If you get stuck, let me know and we can chat about this on our Zoom sessions. Take care.